Okay, remember I can't hear with these things on, so if I ask you to repeat yourself, it's not you, it's me. All right, so in the last lesson, we talked about finding max and mins. What did I have to calculate first before I could even think about finding a max or min? The derivative. And that was the first derivative, correct? Okay. You will see here in this title, we're going to be talking about the first and second derivative tests. We've already kind of started that with finding max and mins, okay? Using these tests, you'll be able to determine where a function is increasing and where a function is decreasing. Now, what does increasing mean? It's going up, correct? Which means it has what? A positive slope. Doesn't the first derivative tell me about the slope? What did we set our first derivatives equal to in the last section? 0, because I wanted it to be at a peak, didn't I? And that's where the derivative would be 0. Okay, so I'm going to take that one step further. I'm not now just concerned with 0. I want to know when it's positive, because what is the function doing if the slope is positive? It's going up, it's increasing. And what is the function doing if the slope is negative? It's going down, it's decreasing. Okay, so that's kind of where we're going with this. And then once you do that, you should be able to make a rough sketch of the function. Okay, if I know where it's going up and where it's going down, I should know the general shape of what this thing looks like without actually graphing it. Okay, so we just talked about this. What does the derivative tell us about the graph of a function? We know that the first derivative is the slope of the tangent line. Keyword there being slope. And slope is rate of change. Yes? So if we know what the rate of change is, then we know whether or not it's increasing or decreasing. Okay, that's the whole goal of today. Good? Okay. Thus, the slope of the tangent line can tell us whether or not a function is increasing or decreasing over a specific interval. All right, so take a look at this function. Just because I'm curious if you remember, what type of function is this? What would the highest power be? 4. First of all, I noticed the arrows point the same way, correct? That means it has to be even. Okay, then if I count the number of turns, there's 3 terms, and the power is always 1 more than the number of terms. In this case would be 4. Okay, if a function is increasing, then f prime of x is also increasing. So on this graph, we are increasing here. Good. We are increasing here. Everybody all right with that? On this graph, if a function is decreasing, then the derivative, maybe we'll put this in red, is also decreasing. Okay, and that happens here and here. Good? So what about here, here, and here? Say it again. It's not changing because it's what? It's constant, and what is it equal to? 0. What are these points called? Critical points, because they're max and mins, aren't they? Okay, so what we just learned is kind of funneling us into what we're doing today. We already found the max and mins. Now we just got to then determine, are they now increasing or decreasing on either side of those? Okay, take a look. What are the critical numbers of this graph? 0 and 1. Okay, you would have been able to find those given what we did last. Now we're going to determine how to figure out if it's increasing or decreasing. Okay. Another one, what's my critical number here? 0. Is that a max or a min though? It's not. Okay, so that would have been a function, or excuse me, a point where you would have found it in your derivative, and then when you put it back in, it would not have given you a max or a min. Notice that it's increasing on both sides, so it doesn't have a chance to be a max or a min. Piecewise function, same kind of thing. All right, so here we go. We're going to look at this visually and see if you actually are picking up what I'm laying down here. I want to know what the largest open interval on which f is increasing and the largest open interval on which f is decreasing. Now, is this the graph of the function or its derivative? The function. It just says f, doesn't it? So tell me, where's the largest interval where this thing is increasing? From 0 to 6. Now it says open interval, doesn't it? So I have to leave it open. Fair enough? Where's the largest open interval where this thing is decreasing? 9 to 10? Is everybody okay with that? Could you also say from 6 to 8? Which one's bigger? 6 to 8. Open means you don't include the endpoints. That was like, yay. We haven't talked about that in a while. Way back in August when we talked about like half open, half closed, bounded and unbounded. Does that ring a bell to you? A long time ago. Okay, but that's what open means. If they say closed, then I want brackets. How about over here? Largest interval where it's increasing. Four to 5. Okay, everybody agree it's increasing there? I don't know that that's the largest. 6 to infinity. You see how that one has an arrow and this one doesn't? Okay. How about decreasing? 5 to 6. So this is definitely decreasing. Is it the biggest? Say it again. I really can't hear. 1 to 4. That's definitely bigger, right? The only other one I could check is this one, right? What is that guy? -1 to 1? -3 to 1. They're the same size, aren't they? Correct. How the length of the x coordinates that it covers. So here, I would write both of them because they're both the same size. Oh wait, they're not both the same size. Are they? Nope, this one's bigger. This covers 4 x values, whereas this one only covers 3 x values. Okay, good. Okay, given the graph of, okay, so how is this different? It's the derivative. This is not the original function. This is now the derivative. I want to determine where the function is increasing and decreasing. Okay, now, first things first, what kind of a function would this be, the derivative? Squared. So then the original function must be a cube, okay? Now, if this is the derivative, where is the derivative 0? This is the derivative, isn't it? Where is the derivative 0? You guys agree that if this is the graph of the derivative, this is where the derivative is 0, correct? Which means these 2 points would have been a max and a min. Agreed? Okay. What do we know about the derivative up here? What kinds of numbers are these? They're positive. If my slope is positive, what's happening to the original function? It's going up. So this is telling me that this function is increasing here. Now, I know my derivative is going down, but I want you to think about it. This is a cubic, isn't it? Do you agree that this slope is increasing? Do you agree the slope is steeper here than it is here? So actually the slope is getting smaller because as I get up here, it's less steep, isn't it? So that's what's happening here. My numbers are really high, my slope is really steep, but then as I get to here, my slope is flattening out. Are we going okay there? Yes? Then when I get here, what's my slope? Which it is, right there, right? 0? Then what happens to my slope? It decreases, doesn't it? But at first, the negative numbers are very small, and then it gets steeper, doesn't it? So the negative numbers get even more negative. Fair enough? So all of this is decreasing. If you look at this cubic, would you agree it is steepest right there? Going down, it's steepest right here, which corresponds to this right there. That's as low as it goes, correct? And then do you see how it starts coming back up? Because I'm starting to flatten out again, aren't I? And then I get here, and I'm right here again, aren't I? Yes? And then what happens? Then it starts to do what? Because isn't this positive now again? So now we're on the back increasing, and it's positive. Do you agree that this thing gets steeper the farther we go? So this derivative is going to get more positive the farther we go. Does that make sense to everybody? It's a shift of the way your brain thinks, okay? So where is this thing increasing? Is everybody all right with that interval? Where else is it increasing? Everybody all right there? So then, where is it decreasing? Is that okay for everybody? Are we sure? Okay, let's try it again then. What kind of a function do I have in the second one? It's linear. So that means the original function would have been squared, which means it's either going to look like this or it's going to look like this. Agreed? Well, if I know about my derivative, I know which one it is. Where is the derivative 0? Everybody good? Derivative of 0 is there. That means that's my max or my min. Now, before the 0, is your derivative positive or negative? Before it. This is positive, isn't it? Which means my function must be increasing. Agreed? Which of these has the function increasing to start? You guys agree this thing starts out going up? Remember, we always read these things from left to right. It's going up, yes? And then after it gets to the 0, then what happens to it? It decreases because my slope is now negative. Do you see how it's below the x-axis? Okay, so that confirms this. Here's my 0. Here the slope is positive because it's increasing, and here the slope is negative because it's decreasing. Fair enough? Okay, so we are increasing from negative infinity to 1, and we're decreasing from 1 to infinity. Any issues on that? When you're looking at graphs, make sure you understand, is it the original function or is it the derivative? Because they're two totally different things. Okay, that went pretty well. Normally, this is kind of a hard concept to wrap our heads around because you're not actually looking at what you're looking at. I know if that makes sense, right? All right, so tell me, let's do this algebraically now. That was visually. Tell me the intervals over which the function is increasing and decreasing, then make a sketch. And no, we can't use Desmos. Kind of defeats the purpose. Okay, so if I want to find out where it's increasing and decreasing, I got to know about the slope, right? Yes? If I got to know about the slope, what do I need to find? The derivative. In fact, which derivative? The first one. Okay, so go ahead. Find your first derivative, please. Everybody good? Set it equal to 0. You should get negative a half. Is everybody all right with that? So what did this just tell me? It's a critical point, right? Which means what's happening here? The graph is turning, so that means it must be a max or a min, correct? What kind of a function is this to begin with? Parabola, correct? So I know it's going to be some kind of parabola. And this point right here is going to be at negative a half. Good? Okay, so if I know this is 0 right here, I'm going to test before it and after it to figure out, does it look like this or does it look like this? Are we ready? What's a number that's before negative a half? Negative 1. Now my question to you is, am I putting this into the original function or into the derivative? the derivative because I want to know about the slope, don't I? So if you put a -1 in here, what do you get? Everybody good with getting a -1 here? Which is negative, correct? Which means, what is the function doing here? It is decreasing. Pick a number after -1/2. 0, what do you get? 1, which means this thing is increasing. Fair enough? Okay, so we can answer part of our question. I know this thing is increasing from -1/2 to infinity, and I know it's decreasing from negative infinity to -1/2. Any issues there? Everybody doing okay? So now I just need a sketch. Well, I know it has to look something like this, doesn't it? And you should know from the original function, is it face up or face down? It's face up. Does our derivative confirm that? It goes from decreasing to increasing. Yes? Okay. So really the only other thing I want to know for sure for my sketch is, my point is at -1/2. Can you just find me the y coordinate so I know exactly where to put my point? What's that? Now, am I going to put it into the derivative or the original function to find the actual coordinate? Original function. If I want to know the slope, then I put it into the derivative. But if I want to know the actual coordinate, we'll put it in. Can somebody do that for me? 1/4, -1/2. Is it +1/2? Oh, nope, you're right, because when you square it, it becomes positive. So +1/4 plus 1/2. No, +1/4, -1/4. So it's 3/4 is what you told me, right? Everybody good on that? We sure? Okay, so all I need now is a sketch. -1/2 3/4 is going to be in the second quadrant, and we said it's face down, right? Excuse me. We said it's face up, didn't we? So this is all I'm looking for. It does not have to be anything special. It is literally just a sketch of what it looks like. 2 ways. It goes from decreasing to increasing. So if that's going to happen, it's got to look like that, correct? From decreasing to increasing. And in your original function, you know that if it starts with positive, then it's going to be face up. Okay, let's try another one. Go ahead and find your derivative when you're ready. How am I going to solve this derivative? Factor it. It's got to be 3x and x. It's got to be 1 and 1. Uh-oh. Does that factor? I don't think that works. I don't think that works, does it? No? Okay. You guys go to this one. I wonder if I maybe wrote the original problem down. Go to number 3. Do that derivative. Nope, I surely don't. Okay, let's come back up to number 2. It wasn't factorable, was it? No, which means, do I have any critical numbers? No, not at all, do I? So what kind of a function is this? It's cubic, right? What do cubics look like? Right? A curve? But it doesn't have a max or a min. So what's it going to look like? Like flat in the middle, okay? It's going to look something like this, right? Or like that, right? I just need to figure out which way it goes. Now, if I'm going to do that, I just need to test some random number in my derivative to see if it's either increasing or decreasing. So pick me a random number to test in my derivative. 0. If you put a 0 in here, what do you get? Is 1 positive or negative? It's positive. So that means my slope is always positive, which means it is increasing, correct? Now, I do need 1 point to put on here so I can make sure my graph is a little bit legit. The easiest point is going to be the y-intercept, because what do I know about every y-intercept? Say it again. The x has to be 0, correct? Very easy to plug 0 into the original function, isn't it? What do you get when you plug 0 into the original function? So I'm going to make sure I at least have one legitimate coordinate on my graph, which would be at 0, -1. And then I can go ahead and draw my increasing cubic function. You guys noticing how I just need 1 point to make sure I'm grounded somewhere and I don't just have a random curve? Okay, is that all right for everybody? Yeah? Okay, did you get your derivative here? Looks like this, right? How do I solve it? Of 2x squared, and then you're left with, how's everybody doing here? So what are my critical numbers? 0 and 3/2, which is 1.5. So I know at 0 and 1.5, I have maxes or mins. I got to find out if they are maxes or if they are mins. Now, before we did that by plugging them in, correct? Now, if I find out if it's increasing or decreasing, I know if it's curved up or curved down. Pick me a number before 0. If you put in -1 to the derivative, do you get a positive or a negative? Is everybody okay with that? Do you agree this will give you a negative? So if it's negative, that means it's doing what? It's decreasing. Pick me a number between 0 and 1.5. If you put a 1 in here, what do you get? A negative, which means it's decreasing, correct? Everybody good here? And then pick me a number after 1.5. 2. If you put a 2 in there, what do you get? Which means it is increasing. Now, do you see how it says decreasing, decreasing? So what does that mean? It's like this one, right? At this spot, it's going to be just flat. It's not going to be a hump or a valley. You okay with that? On that one, this is going from decreasing to increasing, so doesn't it have to look like that? Is that okay for everybody? Okay, so I got to get a couple points so I can be grounded here. I think 0 would be an easy point to do. In the original function, what do you get? 1. And we might as well just go with that 1 1/2 because that's going to tell me where that valley is. If you put a 1 1/2 in there for me, what do you get? Should be a decimal, I think, or a fraction. Yep, that's what I'm getting, -11/16. Is everybody okay with that? That's going in the original function, right? Yes? So now I'm ready for my graph. I'm going to put 0, 1 on here. And I'm going to put 1.5, -11/16 on here. I don't know, maybe like right there. Everybody doing all right? Now, does this graph start out decreasing or increasing? Decreasing, so I have to be coming down. I have to get flat, and then I need to do a valley. Is everybody good on that? Coming down, we're flat, we need a valley, and then we go back up to increasing. Is everybody good there? Now, I didn't write out my intervals like the directions asked me to, but could you write out your intervals here? Yes? This thing would be decreasing from -infinity to what? Is it decreasing here? It's 0 here, isn't it? It's flat there. Yes? So we're going to have to break them up. And then we're increasing. No. This goes to 1 1/2. And then we're increasing from 1 1/2 to infinity. Back on this last one. Over what intervals are you increasing? Do I know that for sure? I don't know that for sure, do I? Did I have a critical number? I didn't have a critical number, did I? It didn't have to be flat there, did it? I could make it like this. That's not flat there, is it? It actually shouldn't be flat because I don't have a critical number. This is just a random point. To ground that. Give me 1 second. This would be increasing everywhere. Good? Okay, so you've got some homework. And it's that. We'll do more of this tomorrow. Oh, Miss Potter? I don't know if you're just hanging out outside my door, like, waiting to get in here. What's up? Oh, yeah, you're fine. They're just going to write down their homework, and they're good.